what I want to be, or what I want you to be able to do on these is to distinguish between what are called necessary conditions, which are just properties that are shared by those particular types of figures, versus sufficient conditions. And we'll talk more about sufficient conditions in the second part of the talks today. Okay, so I just want to go through and we'll fill in the necessary conditions and properties of each of these. Okay, so first we're dealing with a parallelogram in general. Okay, so by definition of parallelogram, a parallelogram is a quadrilateral with both pair of opposite sides parallel to each other. Okay, so that definition gives us one of the necessary conditions for a parallelogram, and that is that the both pair of opposite sides are parallel. Okay, so you know that in any parallelogram, the definition of that term is going to be one of the necessary conditions for it. Okay, so there's a couple other things that you can find out based on this as well, and they require you to go in a little bit more and look at a parallelogram. If you were to draw in one diagonal from your parallelogram, so let's say I draw this purple diagonal here, it's going to cut this parallelogram into two triangles, right? If you look at these two triangles, they both share this purple side. So I'm going to mark the purple side with a single tick mark. Now, the fact that these two vertical sides are parallel to each other, what do you know about these two angles here? They're what kind of angles with respect to those parallel lines? They're alternate interior angles, therefore they are equal, correct? Okay, we can look at the same thing with respect to these horizontal sides that are parallel to each other. If that's the case, what do we know about these two angles? Those are also alternate interior angles that are equal. So in looking at these two triangles now, we have two pair of angles that are the same, the blue angles and the green angles, and we have the side that is included between those angles that is the same. So is ASA a congruence pattern? Yeah, so we know that these triangles are congruent to each other, right? Therefore, by CPCTC, your definition of congruence, all their corresponding pieces are equal as well. So what we know is that this side right here opposite the green tick mark is equal to the side opposite the green tick mark in the other triangle. The side opposite the blue tick mark has to equal the side opposite the blue tick mark in the other triangle. Okay, we also know that these final opposite angles, the angles opposite the purple tick, has to be equal to each other as well. And so by CPCTC, we see that all of these corresponding pieces are the same. So this winds up giving us two additional necessary conditions or properties that exist in all parallelograms. The first is, what do you notice about the opposite sides here? Opposite sides are congruent. And what do you notice about these opposite angles? Opposite angles are also congruent. Okay, so in looking at this, both pair of opposite sides are congruent, both pair of opposite angles are congruent, both pair of opposite sides are parallel. Okay, there's one more relationship that exists here that can be identified when you draw in the other diagonal. So when you draw in this other diagonal, what you wind up seeing is you have this set of vertical angles that are equal. So if we have these two angles are equal, we also see that the sides opposite them in these small triangles in the middle are equal. And then we see that these blue tick marks still coincide with one another. So that gives us two angles and a non-included side. Is AAS a congruence pattern? Yeah. So you know that these two triangles here and here are congruent. Therefore, we can label their corresponding pieces. This side right here corresponds with this side. This side right here corresponds with this side. And so what you can see right here is the diagonals not only do they intersect one another, but they cut off one another into two equal parts, right? Which means that the diagonals of a parallelogram bisect each other. Okay, so these properties are going to be true for all parallelograms. Okay,